Hello everyone, my name is Kieran Lane and I am a part of Challenge 2016 at Georgia Tech. And today I'm coming to you about number 2 on my calculus placement exam. And it reads, if cosine of theta equals -6 with a boundary at half pi and pi, find the exact value of sine theta. And as soon as you see cotan of theta, I want you to think trigonometry. That's very important. Once again, when you see cotangent or sine, think trigonometry. And when you think trigonometry, I want you to think triangles. So let's move to triangles. So first let me explain some, things to make all this make sense. We have a right triangle. And what a right triangle is a triangle with a 90-degree angle, which is denoted here by the box. This symbol is the theta. So if you hear me say theta, this is what I'm talking about. Now, opposite, adjacent, hypotenuse. It is opposite because it is opposite of theta. This is adjacent because it's adjacent of theta. And the hypotenuse is the longest side of a right triangle. So here, let's come down to the 3 basic trigonometric functions: sine, cosine, and tangent. Well, you might say, well, the problem says cotangent. Well, these are your 3 basic ones, but there are others. And to get cotangent, you simply use the inverse of tangent, which would be adjacent or opposite. And you might say, well, why is it in this format? Well, let me help you out with a little rhyme. Oscar had a heap of apples. Once again, Oscar had a heap of apples. Sine, cosine, tangent. As long as you remember in that order, you'll be fine. So, Oscar had a heap of apples. That's how I want you to look at it. So now let's move on to solving the problem. The actual problem. Oh snap, I forgot. Wait. The boundary. The boundary is half pi to pi. Well, now you have to think about the unit circle, which is a 360-degree circle, or since we're talking in radians, it will be 2 pi, 0 to 2 pi. So let's go to our boundaries. Half pi, pi, which means it's in the second quadrant. There are 4 quadrants. First quadrant, second quadrant, third quadrant, fourth quadrant. And remember that cotan of theta equals -6. And if tangent was, Oscar had a heap of apples. If tangent was opposite over adjacent, cotangent is adjacent over opposite. So you can look at it like this: -6 over 1. But so you might say, well, how do you know where negative goes? Well, since it's in the second quadrant, remember the first quadrant. Let me talk about it like this. This is a positive direction, and this is a positive direction. This is a negative direction, and this is a negative direction. So now that you know you got your theta right here, you can now use this as your adjacent, and knowing that this is a negative direction, this will be -6, and this will be a positive 1. So you might say, well, Kieran, now you have this, but where do we go from here? I mean, don't you have to have the hypotenuse to figure out sine, which is opposite over hypotenuse? Well, that's where the Pythagorean theorem comes in. which simply states leg squared plus leg squared equals hypotenuse squared. And you will see it commonly written as a squared plus b squared equals c squared. And that's what I have denoted here. Leg squared plus leg squared equals hypotenuse squared. But to find the hypotenuse, you have to take the square root, which is why I took the square root of 37. Simple enough. Right here. And now I decided to isolate the triangle so that we can solve the rest of the problem. So now you have your theta, your opposite, your adjacent, and your hypotenuse. And remember that sine is opposite over hypotenuse. Oscar had. And you see that opposite hypotenuse. 1 over the square root of 37. But sometimes professors don't want to see radicals in the denominator. And this is numerator, denominator. Numerator, denominator. So to get rid of that, you rationalize the denominator, which means you basically multiply by 1. Because anytime you divide a number by itself, it's 1. Well, simply what happens is you get rid of the radical. So here, the radical goes away because you're multiplying the square root of 37 times the square root of 37, which gives you 37. And the top simply becomes the radical 37. And this is what happens when you put it in a calculator. So thanks to you all for listening today. I'm Kieran Lane, signing out. Peace.